Hello and welcome to a presentation of this paper. My name is Philipp Scharpf. Let me start with our motivation. According to a recent study, a large part of mathematical search queries are formulated as well-formed questions. Search engines typically display ranked lists of web pages or documents. In contrast, factoid question answering systems allow the user to pose questions in natural language to provide quick and concise answers. In this paper, we present our research on factoid mathematical question answering using our open source MathQA system hosted by Wikimedia. The prominent novelty of our contribution is the open source publication of a comprehensive and detailed benchmark for semantic formula search and mathematical question answering on open data sources such as the arXiv preprint repository, Wikipedia, and Wikidata. We present a comprehensive system evaluation in 15 different information retrieval need modes using supervised and unsupervised retrieval. Furthermore, we add a comparison to two state-of-the-art commercial competitors, Wolfram Alpha and Google.
The system supports a variety of question types. First, formula concept questions, such as what is the formula for mass-energy equivalence? Second, geometry questions, such as what is the volume of a cube? Third, relationship questions, such as what is the relation between mass and energy? Fourth, a direct formula input using its latex string. The system supports two languages, English and Hindi. The linked open formula data is retrieved either supervised via SPARQL queries to the Wikidata knowledge base or unsupervised using an index which is created from Wikipedia articles and arXiv document datasets. The system employs the Stanford Core NLP parser to translate words into formulae and the SymPy parser to split formulae into their constituents to allow for calculations.
Before I continue, let me introduce an important term. An identifier is a constituent of a formula defined by the W3 as a variable with no fixed value. MathQA considers both the semantics of entire formulae and identifiers. I will now start introducing the functionality of MathQA on a few demo slides. Here you can see the start screen of MathQA with the language selection and links to examples, the demo video, and code repository. This is a prominent example of an identifier relationship question, where the system retrieves a formula with identifier names, symbols, and values together with the Wikidata source URL, and allows for calculations using user input values. This is an example of a formula concept query where the system retrieves the values of the identifiers, and given the user input, there is a calculation of a result.
An example of a geometry question could be, what is the volume of a cube? Which is answered by the formula below.
An example of an identifier query could be, what is the symbol for mass? Translating an identifier name into a symbol and vice versa.
An example of an identifier relationship question could be, what is the relationship between mass and energy? It is answered by the formula below, along with names for the identifiers and a value for the constant speed of light. Also, the source URL is provided at the bottom. Finally, the system also allows for a direct formula input using its latex string.
If you toggle the language, you can ask questions also in Hindi. The system workflow consists of the following steps: question parsing and classification, index and knowledge graph query, entity linking or relationship extraction, answer candidate retrieval and presentation, formula parsing, and result calculation. MathQA is designed to answer the following questions. What is the formula for a given formula name? What is the property of a geometric object? What is the relationship between specified identifier names? And what is the relationship between specified identifier symbols? To answer entity questions, concept names need to be linked to symbols or strings. Using Wikidata, an additional entity identification number or QID is available. In our evaluation, we compared 3 different sources for mathematical entity linking. Indices created using document article selections taken from the archive, Wikipedia or knowledge graph content retrieved from Wikidata using Sparkle queries. This figure shows how the formula and identifier index catalogs are employed in the semantic search of MathQA to answer an identifier relationship question. We constructed semantic catalogs by mapping formulae or identifiers to words from their surrounding text and inverting the index. The Wikipedia Identifier Semantics Catalog contains a total of 1,670 entries, whereas the Archive Catalog contains almost 100,000. The total number of formulae in the catalog is around 130,000 for Wikipedia and almost 3.5 million for the archive. Our experiments are driven by the following research questions. What is the possible performance of A translation from identifier symbols to names and vice versa, B, a semantic formula search using identifier names or symbols as query, C, a semantic formula search using the formula concept name as query, D, different index sources created from different datasets in comparison, and E, MathQA compared to a commercial knowledge base and search engine. We evaluate both unsupervised formula labeling on arXiv and Wikipedia and supervised labeled formula data queries on Wikidata. Also, we introduce a benchmark for annotated formulae that can be used for further information retrieval tasks. Finally, we compare our system's performance to state-of-the-art competitors. In the unsupervised formula labeling, we evaluate the translation from identifier names to symbols using the ranking measure discounted cumulative gain. The supervised retrieval is carried out using Sparkle queries to Wikidata, where users around the world collaboratively curate labeled formula data. This table shows the result of our evaluation. We compare both top 1 accuracy and the discounted cumulative gain ranking measure to identify the best approaches, which are subsequently deployed as the system's default modes. We persist the labeled formula data with Wikidata QRDs or URLs as formula concept benchmark. The benchmark selection is openly available in the benchmark database MathMLBan. We compare the performance of our system to 2 commercial competitors, the commercial knowledge engine Wolfram Alpha and the commercial search engine Google. The results show that while Google outperforms both MathQA and Wolfram Alpha in retrieval performance, it almost cannot provide the calculation functionality on our test dataset. MathQA slightly outperforms Wolfram Alpha and yields almost equal results for the calculation availability. So in our paper, we introduce a benchmark for mathematical question answering in 15 evaluation modes on open formula data. The selection and results are persisted in the MathMLBan and MathQA repositories. To reproduce the results and potentially compare and present improved systems. This is required since Wikipedia and Wikidata are constantly changing. Employing open databases such as Wikidata for question answering, one can profit from a constantly growing community-curated collection of world knowledge. However, there are some drawbacks such as data model impermanence and content change. We noticed 3 challenges that prevented the system from constantly providing the same results. First, Wikidata users deleted the defining formula for some items. Second, Wikidata users changed the formula identifier data model. And third, in the geometry items, the object attributes can be modeled in multiple ways. In summary, formulae can always be deleted from or shifted to other items. Also, different properties may be used to store identifier semantics or geometric attributes. Besides, different hierarchical sequence schemes may be used. To make our system more robust, we introduce a cache with an alert in case changes cause a previously working query to be broken. An interesting research question would be to track such changes to predict potential extensions using rule-based or statistical machine learning. This will help the system to auto-repair, searching for identifier information by employing semantic similarity metrics. I now summarize our results. In the identifier symbol name question answering, the symbol to name conversion performs better than the name to symbol conversion. In the identifier relationship symbol name question answering, querying by identifier names outperforms querying by identifier symbols. In the formula concept name question answering, Wikidata performs better than Wikipedia and the archive indices. MathQA with 52% slightly better performs better than Wolfram Alpha with 48%, but is outperformed by Google with 68%. Google only provides calculation possibilities in one case, 2%, while MathQA in 80%. In the identifier name and symbol index evaluations, Wikidata outperformed Wikipedia and the archive as source in terms of both top 1 accuracy and discounted cumulative gain. Based on the results, we decided to choose Wikidata as source for the live version of MathQA, since it intended to only display the highest ranked formula. In contrast to the other indices, which were fixed snapshots of the NTK 11-12 benchmark evaluation datasets, Wikidata is constantly extended. Using the best performing mode, we compared our MathQA system to a commercial knowledge base and calculation engine and search engine. The advantage of our system over the commercial competitors is its transparency, being open source and working on linked open data. Moreover, Wolfram Alpha and Google can only answer formula concept name questions and not identifier queries, which are 12 of the 15 examined modes. MathQA is available hosted by Wikimedia. Let me now conclude. So in this paper, we demonstrated how mathematical entity linking and unsupervised formula labeling can be used for semantic formula search and mathematical question answering. We implemented a system, MathQA, that can answer factoid natural language questions yielding a formula. We tested our system and retrieval methods on a selection of annotated formula concepts. We evaluated over 5,000 results in 15 different modes using formula and identifier names and symbols and strings as input or output, and Wikidata, Wikipedia, and the archive as source for the index. Our MathQA system is intended to aid students and researchers from STEM disciplines, science, technology, engineering, and mathematics in finding formulae by querying concept names or identifier relationships. Students can get an overview of identifier relationships to understand connections between different identifier concepts better. To the best of our knowledge, there's no comparable search engine available so far. In the future, we will also implement the question type, what is the name of a given formula string? This is the classical mode of a formula search engine, and we concentrate on the reverse modes, so searching formula strings by names. Moreover, we aim to automate the index construction from archive datasets or Wikidata, Wikipedia data dumps. MathQA should also return links to archive papers or Wikipedia articles, possibly with a surrounding text passage. Another important step is to include the units of the identifiers. However, the Wikidata knowledge graph, still needs to be completed with this information. Thank you for listening. I'm now very much looking forward to our discussion.